one. Okay, good morning, everyone. I hope you are doing well. And today we're going to be talking about according from the polygons and the quadrilaterals. This is the extension of the geometric shapes, right? In the last class, we studied with more details the classification of the triangles by means of their angles measures and their size. Remember, a triangle is the geometric figure, is a polygon or geometric figure who has three sides. The classification of the triangles according to their number of sides can be determined by a right triangle, isosceles, or equilateral isosceles, or scalene, right? Remember, isosceles triangle is a triangle who there's the two legs are congruent and the base will be different. Okay, the equilateral triangle is a triangle who their three sides will be congruent or equal. And scalene, that means that we're going to have a triangle with different lengths of the sides. I mean, the three sides will be different. None of them will be equal. And according for their angles, we have an angle angle that measure the three angles that will be smaller than 90 degrees, every one of them. The right angle, what does that mean? That means at least we're going to have one singular angle of 90 degrees. And the obtuse triangle, that means at least one angle that's supposed to be superior than 90 degrees. And it doesn't matter what kind of triangle we're talking about in this situation. The theoretical part says that measure the interior angles of any triangle. It doesn't matter if it's obtuse, right angle, or acute angle, that will be equal to 180 degrees. Okay. Now, what we're going to do, we're going to learn an extension of these polygons. In this case, we're talking about the polygons and quadrilaterals. What does that mean, the word polygon? Polygon, as soon as you can read in the theoretical part, is a closed plane figure whose sides are segments that intercepts only at their endpoints. Okay. Poly, that means many. Gon, size. Well, in the intersection point, I'm going to create a geometric shape. Okay. For example, as soon as you can see in the left column, we have a cross, just like a red cross. As a matter of speaking, this is going to be a polygon because we have some intersection points located over there. Another polygon, we're going to have a triangle. We are not specifying this is a right angle or not, but remember, we have three intersection points that are going to create geometric shapes. And another one could be a rhombus or a kite because we're going to have a four intersection points. Okay, and what will be, remember, definition of polygon, simple merely words, poly, that means many, gun size, many size. This is the etymology of the word polygon. And remember, we're going to have a picture or a geometric shape with the, by means of the intersection points, okay? And what will be the difference between a polygon and a regular polygon? Simple. The difference between a normal polygon, regular polygon is simple. A polygon, I never said the side will be congruent, but the regular polygon, that means that the magnitude or the measure, their sides will be congruent or the same measure. For example, we have three pictures. For example, in this the first one, how many sides do we have in this picture? Guys, would you like to tell me how many sides do we have? Mhm. In the first picture, how many sides do we have? We have
Six.
six, right? What does that mean? The name of this polygon will be hexagon because it has six congruent sides. The second one, how many sides do we have?
Five.
Five, right? What does that mean? That means five congruent sides. The name of that polygon, that will be a pentagon because we have five congruent sides. And the last one, obviously, this is a quadrilateral because it has four congruent sides, but the name of this one will be a square because the square we're going to have four sides congruent and obviously a right angles. Okay. We have the difference between a polygons and regular polygons. Remember, the regular polygons, that means we're going to have the magnitude, their size will be congruent. All right. And according from that classification of these polygons, we want to differentiate between convex and concave polygons. Well, you can see the picture of the polygons. A polygon is convex if the segment joining at two interior point lines completely with the polygon. And the polygon that is not convex is called concave. Well, we can see the difference between them. Just for clarify what is the difference between convex and concave. All right, let's think, bueno, vamos a, para diferenciar entre lo que es un polígono cóncavo y convexo, le voy a poner un ejemplo bien clásico. Ustedes han visto que la mayoría de los señores, bueno, en especial cuando pasan los 40 o 50 años, o algunos cuando están 30 años, ustedes han visto que se cargan aquella panzota, ¿cierto? Aquella panza que parece que se hubieran tragado una pelota de baloncesto y que les va a reventar. ¿De acuerdo? Y que se salen del pantalón y se le miran el ombligo. Bueno, entonces esa panzota que sale hacia afuera, podemos decir que es una figura convexa. ¿Por qué? Porque hace la chibolita hacia afuera. ¿Me explico? Ahora, ¿qué es cóncavo? Cuando viene una persona y dice, pocha vos, que semejante panzota tenés, ya te va a reventar el pantalón, ponete dieta, y viene la persona, está en periodo de negación y dice, no, ¿quién dice que estoy panzón? Y empieza lo que nosotros decimos comúnmente, asumir la panza, o sea, meter la panza hacia adentro. Entonces, cuando usted mete la panza hacia adentro, eso quiere decir una figura cóncava, o sea que va, la curvatura va hacia adentro. Fíjese bien, este simula la panza del individuo. Entonces, lo voy a remarcar aquí. Esto, miren. Digamos que esta es la panza del individuo que está hacia afuera. Entonces, como aquí le dijeron que este estaba panzón, híjole, dice que no, y aquí está asumiendo, o sea, metiendo la panza hacia adentro. ¿Verdad? Esa es la diferencia entre un polígono convexo y un polígono cóncavo. ¿Ok? ¿Entendieron esa parte? Okay. This is the difference between a convex polygon and concave polygon. Now, let's go into talking about with the quadrilaterals. What is the definition of quadrilaterals? It's simple. Quadrilaterals are geometric features that they have four sides, okay? But four sides, but according for this quadrilaterals, all of them can be classified according from the parallel sides, congruent sides, and if they have right angles or not. This is the classification for the quadrilaterals. And we have the following scheme for what we're talking about. We can classify the quadrilateral in the diagram. For example, we want to start with the rectangle. What is a rectangle? It's a parallelogram. Remember, a parallelogram is a quadrilateral because it has four sides. But what is the difference the rectangle? The rectangle, obviously, that will be, we're going to have a parallelogram with four right angles. But I never said the four sides will be congruent. No, the base will be congruent with the base, but the height will be congruent with the height, but the base and the height will be different. Okay, this is what does that mean when we're talking about a rectangle. Okay, in the second one, the second place we're talking about quadrilateral. What sorry, the second one is the trapezoid. What does that mean, the word trapezoid? The trapezoid is a quadrilateral because it has four sides, as soon as you can see, with exactly one pair of parallel sides. What is the meaning of that situation? That will have two different bases that will be parallel. Remember, parallel lines are the lines who has this, the same direction, but never touches each other, okay? Not necessarily will be congruent, but if you see the upward base, there has different sides and downward base, okay, the top and the bottom. But both lines will be congruent, but never touches each other. This is the diagram of the trapezoid. The next one, we're talking about the parallelogram. Just what I said. A parallelogram is a quadrilateral and a quadrilateral is a parallelogram because it has four sides. And what will be the terminology we can talking about? Well, because their opposite sides will be parallels and congruent, obviously. The base will be parallel with the base and the height will be parallel with the height. But if you see the picture, this parallelogram, there is no right angles. Only we have a parallel sign. There's a couple arrows, the horizontal and vertical lines. That means parallel. Okay, this is the definition for this parallelogram. And another definition, we have a square. Well, it's a parallelogram because it has four sides. But what is the difference, the square between rectangle, trapezoid, and parallelogram? Well, we have four congruent sides, okay? And also we have four right angles. In the rectangle, we have four right angles, but it never said the four sides will be congruent. But in the square, the four sides will be congruent. And also we're going to have four parallel, four right angles, okay? And the rhombus with the square, it has some kind of similarity because in the rhombus, this is a parallelogram also with four congruent sides, but it never says we're going to have a four right angles. Okay, this is going to be the difference between the square and a rhombus. And now there's another technical part. If you remember at the beginning of the lesson, we start that I mentioned, it doesn't matter what kind of triangle do we have, the addition of interior angles that will be equal 180 degrees, right? Well, in these quadrilaterals, that measure the interior angles that will be equal 360 degrees. Why? Because it has four sides and every side have a right angle. If you multiply 90 times 4, that will be 360 degrees. This is going to be the difference between these parallelograms and right angles. Do you have some questions up to this part? Or everything's clear? Did you copy already or not yet? Yes or no?
Not
No?
yet.
Not yet. Okay, let me change again the camera view. Hold on a second. Speaker, I'm going to pause recording. Okay, continue. In this first example, we must try to looking for what will be the value from X. As soon as you can count the number of sides of this polygon, we have 1, 2, 3, and 4 sides. Obviously, this is going to be a quadrilateral. Remember the theoretical part of this polynomials that says the addition of the interior angles of any polygon, in this case quadrilateral, that will be equal 360 degrees. So what we're going to have, we're going to add the entire angles. We have x plus 2x plus 1 plus 68 plus, don't forget this right angle, that will be 90 degrees. And this is going to be equal 360. Remember, we have 1, 2, 3, 4 angles. Obviously, because we have 4 sides, we're going to have 4 angles. And the addition of the interior angles, that will be equal 360 degrees. Well, let's going to apply the like terms. 1x plus 2x, that will be 3x. Plus, if you add 1 plus 68 plus 90 degrees, that will be 159. 159, and this expression, that will be equal to 360 degrees. And we have to solve for x. Remember, 3x, that will be equal 360 minus 159. Okay, and the subtraction between them, that will be 201. 3x equals 201. And x, that will be equal to the division between 201 divided by 3. For that reason, the value from x will be 67 degrees. Questions? Understood the first example? Okay, then. Let's see what we got. Let's go into talking, looking for another example. In the example number 2, it says, classify the quadrilateral, classify the quadrilateral and find the value of y. And find the value of y. Okay, let me draw the picture of the problem first, and let me know, and you let me know what kind of quadrilateral will be this one, and what will be the value of y. Okay. This side will be parallel with this one. In the measure the angle, we have y degrees, y degrees, 130, let me see here, 137 degrees. The another one is 97 degrees. And the last one will be 2y minus 3 degrees. This is going to be the example number 2. Okay, guys, would you like to tell me at the beginning of the problem, what kind of quadrilateral is this one?
A trapezoid.
That will be a trapezoid. Simple, because a trapezoid, remember, is a quadrilateral who has exactly one pair of parallel sides. Exactly, you're right. It is a trapezoid. I'm going to write this classification. It is a trapezoid. Es un trapezoide. This is the first question. Classify the name, determine the name, the quadrilateral, and solve for y. Remember what the theoretical part says. The addition of the interior angles for any quadrilateral, that will be 360 degrees. For that reason, we have the value from y plus 2y minus 3 plus 137 plus 97 equals 360. This is the theoretical part that we were talking about. Now let's going to reduce this expression, apply like terms. 1y plus 2y, we have 3y. Now, the addition between -3 plus 137 plus 97, that will be 231. 231, and that will be equal 360. So 3y, that will be equal 360 minus 231. So that will be equal to 129. 129. And because we're looking for y, this number 3 is multiplying, passes to divide. So 129 divided by 3, that will be 43 degrees. And this is going to be the solution set of the example number 2. Questions? ¿Estamos claros hasta ahorita? Perfecto. ¿Puedo borrar esta partecita que dice el polígono cóncavo y convexo? ¿Puedo borrar esta parte?
Sí, mister.
Bueno, vamos ahorita. Permítame, pues. Uy, como les decía, esta última sección es mucho la más complicada de las secciones. Es la unidad 2 cuando estudiamos los triángulos. Esa es la parte más complicada. Y ahí la primera unidad, y estas son las más fáciles. ¿Allá puedo borrar o todavía no?
No, eso no, mister.
Ok, bueno. Mientras tanto, vamos a ir buscando otro ejemplo. We have this problem. Okay. The example number 3. Use the figure shown use the figure shown to find the measure of the angle. This is not m smaller than, no. In geometry, in this geometric picture, this m that means measure in the symbol that represents angle. Measure of the angle y, wxy, and measure the angle xyz, period. And set, explain your reasoning. Okay, let's do it. Just as I said, the hardest part on this kind of problems is draw the picture. This is a right angle. Also a right angle. This is 45 degrees. This is 60 degrees. Then we have this angle. We have this one. And what else? Yeah, WXY. This is going to be W X Y and C. Okay. All right, just for finish this. In this picture, we're supposed to try to looking for the measure of the angle WXY. I mean, WXY simply merely works this entire measure. And obviously, and after that, the measure of the angle X, Y, and Z. In geometry, to trying to looking for what will be the measure of the angles, always the position of the letter in the middle will be the angle that we're talking about. In this case, because in the first question is find the measure of the angle WXY, WXY, that means what will be the entire measure of this angle. Okay, just for let you know at the beginning. And the second one, the measure of the angle XYZ, that means the measure of this second angle. Let me show you to this far. Okay. The angle of this blue one and obviously the purple one angle. How are we going to solve this kind of problems? Well, simple. The only thing that we have to do at the beginning, we must to separate the geometric picture. Obviously, we have a compound geometric figure, right? But what kind of figure do we have? In the left side, in the right side, we have special right triangles, right? Because this is a triangle 45, 90, and obviously this is going to be 45 degrees. This is by one hand. By the other hand, we got the angle given by 60 degrees, 30 degrees, and another one that's supposed to we have um, a triangle or an angle of 90 degrees. So the first thing that we must do is separate the three geometric figures. I mean, we can have the first triangle. Once again, let me show you what will be the measure for the first triangle. We have obviously the 90 degrees over here. We have 45 degrees, and we really need to know what will be this, the measure this angle. We call this angle theta, okay? How we can going to calculate the measure of this angle? Simple. The measure of the entire the interior angles of any triangle that's supposed to be 180 degrees. So we have theta plus 45 plus 90 degrees, that will be equal 180 degrees, right? Right? And if you add 45 plus 90, that will be 135 degrees equals 180, okay? And if you solve for theta, we must subtract 180 minus 135, and also that will be equal 45 degrees. Okay, this is going to be the first answer. I mean, taking the value for this angle, only for this position, 45 degrees. This is by one hand. By the other hand, we can draw the second triangle. We can draw the second triangle. We have 90 degrees over here. We have 60 degrees. We can call this one like a W. And we can apply also the same theorem. I mean, we can call this one like a W plus 90 plus 60 equals 180. Okay. And W plus 150, that will be equal 180. And if we solve for W will be equal 30 degrees. Because if you subtract 180 minus 150, that will be 30 degrees. What is the meaning of this situation? We have 45 over here, and we have 30 degrees over here. Would you like to tell me What kind of quadrilateral do we have in the middle? ¿Alguien me puede decir qué clase de
A
cuadrilátero?
rectangle.
A rectangle, right? And if you read the definition of the rectangle, says it's a parallelogram with 4 right angles. What does that mean? That means if we draw up this picture in the center, let me do it over here. We have a right angle over here, right angle over here, right angle over here, and a right angle over here, right? Yes or no? But the problem says we have to looking for what will be the total measure of this position. I mean, you know, this part will be 90 degrees and another one will be obviously 90 degrees also. So we have to looking for what will be the total measure of this purple line and what will be the total measure of this blue line. It's simple. The only thing that we have to do to try to looking for what will be the measure of the angle WXY, it's simple. We're going to add 45 degrees plus 90 degrees. For that reason, the measure of the angle WXY will be 135 degrees in the first place because we must to add these couple angles. Understood into this part? Understood? All right then.
Yes,
And
mister.
to try to
Yes.
looking for the second one, same happens. I mean the measure of the angle X, Y, and Z, that will be equal to 90 degrees plus 30 degrees. So the measure of the angle XYZ will be 120 degrees. And this is going to be the solution set for the third problem. Okay, questions? Okay, let me take a print screen. I did already. And I send you in the WhatsApp group. Ah, ay, me salió esta parte, pero déjenme tomar otra foto porque salió muy feo esto. Esperen. Ya les voy a mandar otra fotito. Vamos a buscarle acá, permítanme. Otro print screen. Yep, ahora se los mando al grupo de WhatsApp. Perfecto. Bueno, mis estimados aprendices, yo creo que hasta nos pasamos unos 5 minutitos. Lo vamos a dejar hasta aquí. Gracias por su fina atención. Esta clase lo voy a subir el día de hoy y ya se los mandé también la copia por el grupo de WhatsApp, ¿verdad? Por si les faltó algo. Dios los bendiga, los guarde, los cuide. Si Dios permite, los veo mañana en el colegio. A no ser que nos den el comunicado que tenemos que seguir en online. Bendiciones. Cuídense mucho. Bye, bye.
Bye, mister, cuídese.
Igual, bendiciones, muchachos. Bye.
Bye.
Bye, bye.